Today we're going to learn about AI regulation and the classical AI metrics to evaluate in AI models. So we're going to start with understanding the bias in AI. There are different types of bias such as sampling, algorithmic, historic, and evaluation bias. And for example, I was looking into credit application case study and evaluating the bias that might be introduced. So bias could mean different for different case study and different metrics. So the very common user case of bias will be not having a diverse set of data set or a diversified attribute. And yeah, so the problem is if you do have a bias in your data set, what it really means is you have a unrepresentative test data and inadequate metrics, and you're gonna fail to consider the sensitive attribute as well. And the impact of this could be misleading conclusion, so not having the result that you want, and also a kind of being not able to make a good decision from that data set and continuing to have more bias. But again, it could be different for every model, but again, not being able to tackle the bias from very early stage could actually impact your model going forward. So yeah, try to tackle the bias from a very early stage. And also now we're going to talk about the mitigation. We're going to talk about the mitigation for evaluation bias. There's different ways, and if you're working with LLM, you need to know about this a bit more. LLM is trained on unlabeled data, so if you're trying to fine-tune your model, you need to look into the ethical consideration. But again, for any model that you're working with and you're looking into evaluating and reducing bias, you need to consider diversifying the evaluation data or any data, looking into fairness metric as well, and the ethical consideration, and also look into explainability and understanding how the outcome might look. Evaluation metric in machine learning. So there's two very classic one, the classification and regression, and that's what we're going to talk about in this video. But yes, so evaluation metrics are used to evaluate the performance of machine learning model. These metrics are quantitative measure that tells us how well a statistical or machine learning model is performing. So evaluation metrics will differ based on the type of machine learning models. As I said, there's different methods of doing evaluation for every different type of model. So it will be different for LLM, and it will be different for if you're doing more of a smaller size model. But this is the classical ways for the classification and regression. That's what we're going to talk about in this video. So what is a classification model? Classification models are sorting mechanism. So binary classification models are designed to classify or sort a given data point as belonging to a target group or not. Example will be classifying emails as spam or not spam. A perfect classification model will correctly sort every piece of data, but as you know, real life is not perfect and clear-cut or always predictable. A model performance is based on the relative proportion of a bunch of different possible outcomes, which is like the prediction comes in for any given observation. So this is where prediction is really, probability is really useful things to know about if you are studying machine learning. So you can see we have an example of how it works. So the possible outcome, so key terms used to describe each of these outcomes with the help of the email example that we just talked about. So the false negative side, and we have the true negative side as well. So false negative is, so if you look at the false negative, so this is where the email is tagged as not spam and it is spam, so the FN. Then we have the true positive, which is a TP. The email is tagged as spam and it is actually spam. And then on the other side we have the true negative TN. The email is tagged as not spam and it is actually not spam, so which is actually the true, it's not spam, so it's tagged as not spam. And the false positive FB, the email is tagged as spam but it is not spam. So the precision, which is a evaluation metric, looks at so it consider only the points inside the circle. So whatever is inside the precision, will look into that, the true positive and the false positive. So evaluating metric of classification. So these are the metric. you can't really see, it's quite tiny, so I do apologize, but I'll just talk about what it means. So what I'm talking about, so we have accuracy, so we're just looking at the overall correctness of the model. In other words, it measures how often the model correctly assigns a label to a data point. Example, how often is spam label is not spam, and how often is not spam label is not spam. And then we have the precision, which measures how accurate prediction are when you predict something positive. It's all about how reliable your positive prediction are. Measures how good the model is at labeling data in the positive category. Then again, accuracy and precision should not be used in isolation, because if we only calculate the precision, it may seem like our model is working well, but although the model is predictable and really good at throwing darts in the same spot, but missing the intended target. So yes, this is why you need to make sure accuracy and precision both are there. Also, there are other things that the model is evaluated on, like such as recall and F1 score, which is really popular. So the recall shows how well the model identifies a target positive category, and then F1 score reveals the balance between the precision and the recall. So the higher the F1 score, the better the model performance. It shows if the model is good at accurately labeling data and finding all the important data. So this is for the evaluation metric for classification. Although I'll keep this video really short, so I'm not going to talk about the evaluation metric for regression, but I will in the next video. So please do like this video so I can make more videos. And yeah, this more stuff like multi-class classification models, so which is same way evaluated, but also these regression models, which is slightly different. So regression model looks at mean absolute error, mean squared error, root mean squared error, and the R squared, and there's also a F1 square and all those kind of thing. But I will talk about all this in the next video, so please do like and share and comment. Thank you.